Hi there, this is session 12 of programming from the very basics using Python. In this session or in this video, I will talk about using the while loop in Python. I covered how to use if conditions in the previous session, so do have a look into those sessions if you have missed them. So I will continue with while loop in this session now. So the while loop is a looping construct. What exactly are looping constructs in programming? Well, we have a couple of statements, right? Instructions. Let's say you want to repeatedly execute the instructions over and over again until some condition is met. We use a loop. We do this in real world. In real world, we constantly poll for activities. Let's say that uh, I just let's say put some clothes in my washing machine and I turn it on and want to and the washing machine is doing the job of washing clothes and every now and then I need to go and check what's going on. Well, in real world, some good washing machines will beep when it's done, but every now and then I want to see what's the progress. So it's a kind of loop where I frequently go and monitor what's going on until the washing is done. Or maybe I can be reading a book while there's no power in my house. Let's assume there's a power cut and there's nothing I can do. So maybe my mobile is down, so I can't do anything else. So while the power is down, I can keep reading a book. Or maybe while I'm waiting at a stop, let's say it could be a train stop or a bus stop or maybe any kind of public transport. Let's assume maybe it can be even in an airport, right? So as long as I'm waiting for the vehicle to arrive, I can keep reading a book or I can be listening to music. This is a kind of a conditional looping because we're constantly doing one job continuously over and over again until some specific condition is met. So we can do that in programming. So in fact, in programs, if at all I want to, let's say, execute a series of statements until some condition is met, we can use a while loop in Python. There's also another kind of loop in Python called the for loop, which is also meant for executing statements in a repeated manner. But rather than checking for a condition there, you do it in a more uh, deterministic manner where you'll say, I want to execute or definitive manner. So I want to execute some series of activities 10 times or 20 times or something like that. We do that in real world too. For example, we normally have 3 meals a day. It's three. Okay, sometimes we can have a snack in the midst and all that, but let's assume we have 3 meals a day. Or I can say for 5 days a week, I want to work. So 5 days in a week, I want to work and perform some activity. These are like definitive execution. So I want to execute some statements this many number of times, which we predetermine, right? This is also called as a deterministic iteration. That's what for loop is meant for. Now, in this particular topic, we'll focus more on the while loop. So I'll give you how to use it with some basic examples. Let's start with the first example I'll talk about is, let's say, uh, a number guessing game. Let's assume that. In order to explain this number guessing game or even use this example, I need to cover some things. For example, let's say I want to generate a random number, right? So if at all I want to use random numbering or generate any random numbers and so on, there is a standard library module called random. So you can just use import random. The random module, just like sys and time module gives you all the time related functionality. We covered that a bit in the previous session. There's a module called random in standard library, which provides basic random number management functions. So there are different functions available. The function that I will use for this particular example would be a function called random.randint. Should also note that if you load a module, all the functions of a module are accessed like an attribute. It's like module dot attribute. Attributes are ingredients of an object. Somebody might call this methods, but in Python, I can say methods are also just attributes, just that they are callable attributes. You can call them like a function. That's what it is, right? Functions are callable attributes of a module, right? So I can just use random.randint of this takes 2 arguments. And one of the things I have never been talking about when I use VS Code is this tooltip that comes up. See, the moment I open a parenthesis for most functions. You have seen me doing it, and you'll see some pop-ups coming up in here. This is the IntelliSense, what they call at work, perhaps. So this gives you a hint on what arguments it takes. It takes two arguments, A, an integer, B, another integer. And it says return random integers in range A to B, including both endpoints. Let's say if I say random.randint of 10, 20, it generates random numbers between 10 and 20. 10 and 20 is inclusive. I can keep rerunning this cell. I keep rerunning this cell. Oh, sorry. I think I hit the wrong key. Yeah. Rerun this cell. Every time I keep rerunning this cell, you can see it generates numbers. Like sometimes this time it generated 10, sometimes 11. It's quite random. Sometimes numbers could also be repeated. You can see that. Numbers are generated in a very random manner. So why am I using this? To show this number guessing game. Let's to demonstrate this number guessing game. So let's say that I want to take input from a user within a range. Ask a user enter a number between 10 and 20, let's say, and I want the user to enter a number that is predetermined. Let's say I predetermine a number. Let's assume I'll call the number, let's say number is equal to random.randint of 10, 20. When I run it like this, whatever is written by randint is now represented by a variable called number. And I don't know what that value is until I print it. So I have to print number to see that. Here's what the game is. I want to guess this number through a game. So in order for me to guess this number through a game, I'm going to use a while loop here. The while loop will start off like this. First, I will initialize a variable which is required for this logic. I'll initialize it to 0 to begin with. And now I'm just going to try while guess is not equal to number. You know what this means? This condition will be, this particular Boolean expression will return true for the first time. The reason? Random.randint will generate numbers only between the range 0 to 20, and guess is equal to 0, not 0 to 20, in this case 10 to 20, sorry. So randint generates numbers from 10 to 20. So it could be 10 or 15 or 17 or 18, any numbers. It's never going to be below 10. But I set the value of guess to 0, which means this is definitely not equal, right? I mean, whatever number that's being returned is definitely not going to be a value 0. In this case, we know that. So we pre-initialize with that known settings, and we say while the guess is not equal to number, that means this condition is true. While this condition is true, the while loop will execute any statements in its block. So here I can ask for the user to type guess a number. I can just type input. I can just guess a number between 10 to 20. And whatever the user guesses, I'm going to reassign guess to that. So guess was 0 before. The value of guess was 0, but this condition is now, this while loop checks for this condition. This condition is true because it is not equal to number. So it executes this block, I mean the body of this. And there's only one statement at this moment where I'm expecting input from a user as an integer. So this is going to convert to integer, and the int construct that is. And whatever integer returned by the int construct, I'm reassigning it to this variable. So guess will no longer be 0. It will be the value that the user typed now. And whatever the user typed, I want to check whether it's equal to the number. It's already being checked by the while loop here, right? So we can keep running this across, and we can check for a condition. If at all, we can further again test this condition where you can just say if guess is not equal to number. This looks quite redundant in my opinion, but yeah, 2 times in checking condition here, right? So guess is not equal to the number. We can just say, or maybe you can make it even better. If guess is lesser than the number, we can just print try a larger number. Maybe we can give a hint to the program, a hint to the user. If guess is greater than number, print, try a smaller number. Outside this while loop, outside the while loop, I'm just going to print a message. You guessed it. Now let's run. I'll run this code and then we'll see how it works. So let me try running it now. Let me, okay, I need to just say Control Enter. He's asking guess a number. Let's try a number like say 15. Wow. I guessed it right the first time. Wow, that's amazing. Let's try it one more time. Let's try a number this time as 14. Well, it should print a message. It didn't print a message, did it? Okay, let's try. Let's say 12. Try a larger number. 16. It says, you guessed it right. It says try a larger number twice. I think the output is not coming as expected because it could be because I'm using user input as a part of while loop and also printing. That's a problem when you're using input function repeatedly in a while loop and print them, right, in a Jupyter Notebook like interface. So what I'll do next time is I'm going to save this whole code into a file. And how do I save this entire cell to a file? One option, you can copy it, open a new file, paste it there. But as we know, we can do this the Jupyter Notebook way. Remember how you do this? The cell number is 17. I want to save this to a file. So I can just type %save and then specify the name of the file in which you want to save it. Let's call it as guess the number.py and cell number 17. Run this. Yeah, it's going to be saved into this file. Let's go ahead and run this on the command line, the Anaconda prompt or your actual shell, right? Your Unix shell in this case with Anaconda being loaded. So here I opened up the command line. So if you want to try it out, you can open up your Anaconda command line. I guess you know how to do that. Just go to the search in Windows and search for Anaconda command prompt. You get a terminal window or a command prompt window. And make sure you go to the folder where you save this file. That's more important. How do you do that? CD command, right? dir cd. Try to get used to it. But once you're in the right folder, I think I'm in the right folder already in my setup here. So I think there's a file called guessthenumber.py right here. So let me just try to run this. I'll say Python guessthenumber.py. Oh, there is some error here. Oh, you know why? Because you can see that what I did was imported the random module in one cell here, in this cell. But when I stored it to a file, I only stored this particular cell, not the previous one. So the import random is not there in that file. So this is now run as an independent program. So when you try to run this as an independent program, this problem can come up. When you try to save a cell in a file, the cell expects to be fully complete in its own sense. So all the definitions must be there in it. Unfortunately, the definition for random, that's the importing that module, is in a previous cell. And that's why this error came up. Let me just edit it back. In order to edit this file, you can still use a VS Code. I can go to this file explorer and search for that file here, guess a number. And normally this line gets added. There's just a hint to some editors to indicate what kind of encoding is used for the letters. I can just delete it. Don't really require. I could just put this module import in the beginning, import random. There's a small modification I need to do. You could add that also into the cell to make it more complete in its own sense. So you can save it to a file. Now, once I made this modification and try running it, I guess I saw the error and immediately jumped across and told you what happened. So you can see that the error that showed up last time is when you say Python guess the number.py, you can say a trace back and all these stuff here, but then it shows number is equal to random. This is what is highlighted. It says name error, name random is not defined. That means whatever you're looking for, the word random, Python does not know what that is. So unless you import the module, until you import the module, it's not going to work, right? So now I'll try running this with this modification being done. When I added that line, the import random, it's asking guess a number. Let's try 13. Try a smaller number. Okay, 12. Try a smaller number. Let's say try a larger number. You know what that is? 11. You guess it right. Try running it now. Uh, let's try 17. Try a smaller number. Let's try 13. Let's try another smaller number. Oh, well, let's try 10 again. Oh, guess it right. This time it's 10. Try running it again. If we try maybe 19. Try a smaller number. Let's try 15. Try a larger number. Oh, it's between 15 and 19. So let's try 17 perhaps. Ah, we guess it right. So you can see that this is a nice game, right? Very small game that we wrote, but which shows you how to use all these flow control logic at work here. So you can see that these statements are repeated. The statements are repeated. It's constantly asking for user input until you guess the number right. So you can see the logic here again. So while the number that we guess is not equal to the number that is predetermined by these random.randint, it's going to prompt for user input. And if the guessed number is lesser than the actual number, then it'll just print try a larger number. If it is greater, it will just hint try a smaller number. We can also add another interesting beautification to it where we can add a score. So perhaps we can find out how many times the user is trying it wrong, and based on that we can determine the score. So we could actually say maybe let's assume that let's call this as numtries. Numtries is equal to 0. Initialize it to 0, and every time the user tries and maybe the number is smaller or larger, that means it's not the actual guess number, then you could actually increment this numtries. How do you increment it? The plus equal to operator. It's not it's a augmented assignment. You remember, right? It's a statement again. So it's an operator, but it's a statement operator. So it's a numtries plus equal to 1 will increment the numtries by 1. And you can say you guessed it right in numtries. You can say how many tries it took for the user to guess the right number. So you can save this with this modification in this file. I said Control S to save it, by the way, and you can go back and run this now. And you can try numbers like say 13. Ah, I won. Guess it right in 1 tries. Let's try 13 one more time. Its chances of the random number repeating is like it's probability, right? So it's not. Now you can see it's asking me to try a larger number. Let's try something as 18. Oh, smaller number. So it should be between 13 and 18. So let's try 15. Try a larger number. Okay, let's try 16. Oh, you know what the answer is? 17. But I had to get it right. I took 5 tries. Right? So this is how you can formulate while loops. Mostly you check for a condition. As long as the condition is not met, you can keep executing this series of code. So you can see I'm using if condition here to check for conditions inside further conditions. There are some more embellishments that you can add to this code. For example, what if the user types a number that's like completely out of the range? Let's say you want to put a number like say between 10 to 10. I asked for a number between 10 to 20, but the user types like say 45. Obviously, it's out of the range. You want to print a different message here. You want to print a different message. If the number is not within the range, you want to say, oh, the number is not within range. The number must be between 10 and 10 to 20. You have to just mention that. How do you do that? What changes will you make? So here I'm taking user input, right? And whatever the user typed, the number is represented by the variable called guess. Now, how do you ensure that the number being guessed is actually within a range 10 to 20? What will you do here? Think. I guess you got it right. If you got it right, obviously you have to check for if condition, right? So what we do? You just add a condition right on top here. So I'm going to check if guess is less than 10 or guess is greater than 20. If it's less than 10 or greater than 20, then you can print a message. You could print a message. Number must be between 10 and 20. Sometimes I hate that distraction. It just hides away my code. That's one of the reasons I don't use VS Code in my regular basis. But for training, it's useful because if you're new, I think it makes sense. But once you get used to it, maybe you like it. But after that, maybe you'll get yourself more promoted to something like NeoVim or Emacs or whatever other programmer's editor, right? Which gives you better control. But never mind. So I just put this condition here. But here's a small problem. The problem is this. The guess is less than 10 or guess is greater than 20. It prints this message. But after that, this if condition is anyway going to be checked, right? You can see this if condition is outside this block. This condition block finishes right here. There's a completely different block, right? There's another if condition. So what do you do now? So we'll try to run this. You can see what's the result. But try maybe 45. You can see it prints two messages. It says number must be between 10 and 20. Try a smaller number. You don't want to print that try a smaller number if the number is out of range in the first place. How do you do that? Well, there are two ways to do it. One, you can simply use elif condition in this case, right? You can try using elif condition. The other option I thought I'll tell you is using continue keyword, but this would not be the right scenario. I think using elif is better. So you can use check if this condition is not true. If this condition is true, it's going to evaluate this statement. When is this entire condition true? If guess is below 10 or guess is greater than 10, greater than 20. But if any one of this condition, right, is true, the result is this will evaluate the print function here. It's not going to try out anything else. It's just going to increment num tries and go again into this loop where it is going to ask for the next guessed number, right? But however, if at all the number being guessed is within this range, this condition is not true anymore because the number is between 10 to 20. It is not less than 10. Now it's greater than 20. In such case, it's not going to execute this block. Rather, it's going to check for the next condition immediately. It's going to check if guessed value is less than a number or greater than a number in this case, and then increment num tries anyways accordingly. So let's save this. And now we can just try maybe 34. The number must be between 10 and 20. It does not print the message, the number, try a smaller number or so. It doesn't give me that hint. When if I try, let's say 5, you can see that it prints this message here. But if I try a number like say the 14, or I try a number like say 12, 14, it says try a larger number. Putting 12 there is pointless. You need to try a larger number. Let's try 18. Try a larger number, 19. Oh, it's 20 then. Yeah. Took 7 tries for me to guess it right. So you can see how you can keep improvising the code, adding more functionality based on your requirements. Also, maybe you might want to give a user an option to just bail out anytime. Once you run the program, until the user guesses the number right, it's not going to come out, right? Try this. It can sometimes be annoying to users if you don't have an option for a user to cancel out from a program. So if at all you have this running, let's try a number like say 15. Try a larger number. I'll try 15, try a larger number 15, try a larger number 15, try a larger number 14, try a larger number 12, 13. I'm giving all the wrong answers, but there's no way I want to come out of this program. The more normal case, what you normally do is that if you're running a program on the command line, if you're running a Python program on the command line, all the command line applications written in Python, they handle control break or control C combination. I'm going to try control C here. Control C, you can see it actually throws an exception called keyboard interrupt. This is trapped as a runtime error. So the program is running forever sometimes, and you want to just cancel out a program in Python, you have an option to just type control C to cancel out the program, right? You can also try control break if control C does not work. I've seen some platforms, I'm not sure if it's Windows, you might need to type control break there, but I guess control C should work in all the modern Python implementations, but check it out, right? So type control C, it's like control cancel, right? So this is how you cancel out a command line application running in your shell. Now, maybe I don't want to just type Control C. Maybe the user does not know to type Control C. So what you can do is that you can also give an option where guess a number between 10 to 20, or I can just type in parenthesis or 0 to exit. So I'm giving an option for the user to type 0 in order to tell that I'm done, I'm not interested in this. So how do you give that opportunity? Well, I need to check whether the value being guessed is equal to 0. You know that guess was already 0 in the beginning. But you should also note that because it's going to take user input and reassign to guess, the old value should not matter in this case, right? You should know how your logical flow happens. You should always think in your mind, first, this is 0, this is 0. Well, guess, is it equal to number? It is not going to be equal to number because the random number generator is always going to be between 10 to 20. It's never going to guess 0 until you say randint of 0 to 20. Okay. So in such a case, the guess value must be starting with, maybe you can try -1 then. Okay. Anything. This is like an initial value, which will make sure that the condition fails, right? In this case, guess is not equal to number. This is true. I'm trying to make sure this condition is true in this case, not equal to. And then reassign guess with the input from the user. Once you reassign to this, now if the value is 0, the user types 0, you want to just say thank you and come out. So if you want to do that, you can just type if guess equals 0, guess equals 0, and you could just print thank you. And one, you want to break out of the loop. In this case, right, you want to break out of the loop. So I'll just try to, one, you can break out of the loop, or you can use a built-in function called exit right here. Exit will do. Just using exit, right? So let's try this. Exit is a built-in function which will abruptly exit your Python program. If you want to exit your Python program altogether, you can use exit function. But you should note that exit should not be used in Jupyter Notebook. Okay, so it's not meant to be used in Jupyter Notebook, but it's meant to be used in .py files. It may not work in Jupyter Notebook for all you know, right? It may just flag off an error. Let's try this. If we just try exit here, what happens in this Jupyter Notebook instance? Yeah, kernel crashed. Wow, bad. This is VS Code's implementation of Jupyter Notebook. Try this in a real Jupyter Notebook. It will just give you a warning message telling that exit is not going to work in Jupyter Notebook. It will give you some detailed description, right? But here it says kernel crash, which means you have to restart the kernel. To restart the kernel, I think you can go back here and, or maybe you can just there's a way to restart the kernel here. I think, yeah, this one. I don't see it. Yeah, it's here, I guess. No. Okay. Yeah, there's a restart button right here. You can see this right here. You know, I'm not the regular user of these extraneous features of Jupyter Notebook features on VS Code 2. I'm not a full-time user of it, but yeah, it's an interesting one. You can click on restart here, restart the kernel. And you should know that you should not use exit in Jupyter Notebook. Okay, so you can use it in your normal program, because when you exit Jupyter Notebook, the Jupyter Notebook is a Python program. That Python program exits, right? The whole Python code exits, not just your cell. That's the whole point. So here we save this file and we'll run this and try a number like say 20, try a small number. I want to just give up. So I'll say 0. Comes up completely. Though you can use exit function in certain places, as I told you, like in Jupyter Notebook, it doesn't play nicely. So what do you do there? Well, you can break out of this loop now. You can try using the break statement. This break statement is a simple statement that can be only used inside a while loop or a for loop. This is valid to be used only inside while or for. What does break do? Break will abruptly exit the loop. What does break do? It abruptly exits the loop. But now if it exits a loop, it will still tell you, you guess it right in so many tries. That's not good, right? The program has a bug now. I'll show you that. So if I run this now, run this code, I'll try a number like say 10, try a larger number, 14, try a small number. I just say I'm done. I'm not going to give up. So I'll just type 0 here, but just see what happens. Thank you. You guess it right in 2 tries. I didn't guess it right. I didn't guess it. I just exited. Now, this should not have printed this message. You guessed it right in 2 tries. How do you stop that? How do you stop that? Well, the traditional way of stopping it is by having another condition here. The code is becoming bigger. We are now crossed 20 lines of code. Yay. Right? Okay. So now let's try this. We can just try maybe cancel is equal to false. We call this as a flagging variable or a flag. Most of these flag variables are like booleans, true or false. You'll initialize a flag to some value, like say in this case false, and you set it to true in this condition. If guess is equal to 0, you say thank you, and before breaking out, you can just type cancel equals true. Right? You said this particular cancel, the variable cancel is set to true only when the user chooses to exit this program. Otherwise, it'll remain false. But anyways, you're breaking out of the loop here. But now outside the loop, you can actually go and check if not cancel. The word cancel doesn't read English, right? I'll just say cancelled and change that variable accordingly. Cancelled. Looks like a past tense. Yeah, maybe sometimes overly obsessed with naming variables. Okay. So it reads nicely. If you say if not cancelled, now this print must be inside this block. Inside this block. Right? So you can just say this. Now try running it. Let's try a number like say 15. Try a smaller number. I'm just going to type 11. Try a larger number. Now I say give up. 0. It just prints thank you. It does not print this unwanted message at this moment. If you play it nicely, where you just decide to complete the game, right? 10. Try a larger number. 15. Try a larger number. 18. Try a smaller number. Maybe 16. Oh, I know it's 17. Oh, I guessed it right in 5 tries. This time, it prints a message. But if you cancel out, it's not going to print the message. You can see that when I run this. If at all I type 0 here all the way, just types thank you and comes out. Now you can see what I've done here. I have created a flag variable. I'm setting that flag if this condition is met inside the loop before breaking out of the loop. I'm going to break out of the loop. But before breaking out of the loop, I'm going to indicate that I'm breaking out of the loop. I'm canceling out of the loop, right? So I'm just setting this flag. And then outside, I'm going to check whether the loop was cancelled abruptly, midway, by the user, and then don't print this message. Right? Now I'm going to tell you something that's unique to Python. Very interesting. You won't learn this in many places. Not many of them even are aware of this. Oh, that's the beauty of attending my trainings or watching my videos. There's an else clause in a while loop. This is unique to Python because most languages don't have it. In many languages, you have a if else, that's it. But Python has a if else, while else, for else. Oh, there's a try else. Most of the flow control constructs have an else clause. With does not have it. Match does not have it, by the way. So apart from with and match. So there's a if else, while else, for else. There's also try else. This else clause is there in all these constructs. And it's a very interesting one. There's a very common pattern where you have a loop. You want to keep executing the loop. I want to know whether the loop ran to completion based on the condition failing in this case, right? This loop runs to completion when this condition becomes false. If this condition becomes false, the loop will gracefully exit out. It checks for the condition and exit out. This is like loop completion, right? Thoroughbred completion based on the condition. But if you abruptly exit the loop using a break keyword by using some other extraneous condition checks inside the loop, like if condition in here, and you're trying to break out of the loop, right? How do you know that whether loop exited because the loop condition failed, or maybe because it exited because of some other condition where I abruptly broke out of the loop, right? That can be checked using the while clause. So you don't have to use these flag variables. I'm going to show you how to do that. I'm going to save this file, this whole file. Okay, I'm going to put this. Okay, let me save it in .py file. This file is quite big. I would not write code like this in a cell in Jupyter Notebook. This code is quite big. Jupyter Notebook, you'd use it for small chunks of code. 5 lines, maybe up to 10 lines, you can stand that. But the moment the code becomes this big, it's better off to make it fully complete and put it in a .py file and save it. You know the workflow now, right? Larger code, .py file. Small code snippets that you want to try out independently, there use Jupyter Notebook. That's the use case, right? So I'm going to save this file under another file name. I'll name this more intuitively. Guess a number using while else. I'm making all these names too long so that when you look at the file name in my GitHub repository, if you're downloading it and playing around, you know exactly what this file would contain when you're looking at the name. Now in this version where I'm going to use while else, all I need to do is I can drop this out completely. I don't need it. I'll stick to while guess number, and I don't need this variable linear. So I'm just going to say if guess is equal to 0, I print thank you and just break out of the loop. Otherwise, check if the guess value is less than 10 or greater than 20. Say the number must be within the range 10 and 20. Otherwise, check if the guess number is smaller than the actual number that was generated by random.randint. In such case, print a message like try a larger number, or for the other use case, if it's greater than number, then print try a smaller number and increment the num tries. But now here, this if condition is not required. You know what I do instead? I type else. I type else here, right? Okay, now try running this. So this else is indented in line with the while block. You can see this while and else are in the same indent. That means this else belongs to the while loop. And what is the use of the else clause? The else clause is evaluated only when the loop condition fails and you're exiting the loop. If you abruptly break out of the loop without the loop condition not being met, in such case, the else clause is not going to be executed. That is the difference. So this is a shorter variant in Python where you don't have to have another extra variable which you need to separately check against outside the loop. This looks more complete and more structured. This is Pythonic, I would say. Run this now with using while else. Yeah, I just use tab completion. It's a file that I saved in as. So I type guess the number using while else and guess a number between 10 to 20, 0 to exit. Let's type like some number like say 13. Let's try 12. Oh, 11. Oh, it's 10. Okay, guess it right in 4 tries. Now let's try it one more time. 15. But this time I want to exit from this loop altogether. I'll type 0. It says thank you. You can see that it did not print the message. You guessed it right because that's part of the else clause. So you should note that while else, if you use the else clause with a while loop, the else clause is evaluated only when the loop condition becomes false. It makes sense to use the else clause with the while loop only if you have other means to exit out of the loop, like using a break keyword here based on another condition. Such case, you can check whether the loop exited because of the break or the loop exited because this condition failed. Like that's the use case. Now, when you use an else clause like this, let me do one thing. Let me show you. Maybe I'll put this num just to show you. Okay, I'll put this num tries here. It doesn't matter whether you put num tries above or below. Anyway, the num tries is going to get incremented after it takes user input. After that, I'm going to verify. It doesn't matter. When you have a code like this, Now, an occasional user who has self-learned Python, who has not watched my video, right? Or has not fully completely gone through the Python tutorial to know all these nitty-gritty details. And he's going to look at this code. And he or she will look at this and say, oh, there's something wrong with the indentation. Let's fix it. Whoops. Whoops. You know what happened now? The logic changed. This else clause now is not part of the if condition, not part of the while loop. Do note. The indentation decides your logic now. That's a scary thought that you should have when you are writing Python code. Some people will think, oh my God, I don't like indentation. No, this is bad. But get used to it. That's how it is, right? When you live in the Python world. So here, the logic changes. I'll show you what happened because of that. Your code will work a little weird. So we try numbers like, say, 13. It says try a larger number. Let's say 12. Try a larger number. Try 0. Oh, it says thank you. It came out. Well, because I put 0 there. Okay, I didn't check that. Sorry. Let's try another number. Let's say 55. 12. Let's do one thing. Let's try to guess the number right. Okay, let's do that. So if I try running this code, let's try a number like, say, when I typed 12, it says smaller number. Okay, let's try 10. Try a larger number, 11. Oh, you guessed it right. Oh, okay, it's working. Strange. Okay, I'm surprised to see it's working actually. Okay, because I'm checking the condition anyways. But is it? How did it print it? Oh, okay. Somehow I made it work. It still works. Okay. It's all spontaneity because here what happened was, yes, this condition is false. If this condition is false, that means the number is within the range, between 10 and 20. The number is lesser, the guess value is lesser than the actual number, then it's going to print this message. If it's greater than the number, it's going to print this message. Else, the number is equal. In such a case, the number is equal, it's going to print this message and it's going to exit out. Oh, in this case, it doesn't make any difference. But there are certain times where your logic will change completely, depending on what kind of conditions you're checking. In this code, unfortunately, I couldn't show you that. This worked perfectly fine. Whether you put the else clause with a while loop or if condition, both circumstances luckily worked, but this may not always be the case. So whenever you use a while else block, while else clause here, to be nice to the users who might not know the existence of while else, you might want to put a big, bold comment. The comment would be, do not reindent. Read up on while else in Python tutorial. Or you know what? Just point to this video. Just put a link to this video. Okay, so that's good. All right, in Python tutorial. So this is what you should know about the while else block, right? So this is something you should know about the while loop and how you can use while loop for doing interesting stuff here. I just gave one example. One is not sufficient. I want to give another one. And this is a very interesting example. And this really boggled my mind the first time I read it. It's like, wow, you can do that in Python. And I'll show you that. Let us say you want to find out the HCF, or highest common factor of two numbers. Oh, those of you are a little forgotten mathematics. Even I have forgotten, but because of computer science, all my old math knowledge is sort of resurfaced. I had to go back and read it. But I'll tell you what that is. Given two numbers, let's say 24 and 16, you can find out which is the biggest number that can divide both of these numbers. That is 24 and 16. That's called the greatest common divisor, GCD, in some countries. In some countries, it's called HCF even today. It's called highest common factor. So you can use it as GCD or HCF. How do you find it out? Well, you need to use interesting algorithms. I think we use something like LCM and so on. But there's one of the most innovative algorithms is, I think it's the Euclidean algorithm. Basically, you take these two numbers and you find out which is smaller amongst them. Or in this case, 16 is smaller. So what you do now is you just try dividing the bigger number by the smaller one. So 24 percentage 16. Basically, I want to divide and get the remainder of it. Remainder. Okay. Let's try running it. It's 8. Remainder is 8. What you do now, you take you try to divide the larger number from the smaller number. You got a remainder. Now what you do, you take the smaller number, divide it by this remainder. Divide it by the remainder. So when you do it one more time like this, let's try 16 percentage 8. You get 0. So if you get 0 as the final answer, you have to keep repeating it. Once you get 0 at the final answer, the last remainder that you see here, that is the greatest common divisor or the highest common factor between these two numbers. Here it's so easy, finished in just 2 tries. Let's try some other numbers. Let's try maybe, let me think of a number, let's say 34 and 85. So just sort of thought about it. 34 and 85. Now what we'll do is we will try to divide 85 by 34 because 85 is a bigger number, 34 is a smaller number. Divide the bigger number by the small number and get the remainder. Remainder of division is what you need. So we can try first 85 percentage 34. Returns the value 17. It finishes in just one cycle again. Now we try to take this 34 percentage 17 and then you get 0. So 17 is the greatest common divisor of both 34 and 85. I think it's 17 2s are 34, 17 5s are 85. I sort of remember. Okay, so you can see that. Anyways, so this is how you can find out the highest common factor or the greatest common divisor of two numbers. But this is an algorithm. What is this? This is what is an algorithm. So you have a problem statement. The problem statement is you want to find out the greatest common divisor of two numbers. And now you need to come out with a logic, programmed logic to solve that. And that programmed logic is what we call as the algorithm. Right? And an algorithm is made up of step by step for ways of doing it. And in order to do the step-by-step ways, this is where you use all the programming ingredients like loops and conditions, right? Loops and conditions and variables and statements and expressions. All of the ingredients work together to now solve a real problem, right? I'll show you how to do this now with a code. Let's say I'm going to use a is equal to, let's try another number. Let's say 133 and okay, I'll just take a comma b, okay? A comma b is equal to 133 and 57. Random thought, okay? It's quite random. I don't know whether it's going to work, but let's try. I want to find out if there's a number that can divide both 57 and 133. A common number that can divide both of these, right? So we want to find that out. So to do that, the logic, just watch me do it. This might look a little outlier. I want to give it to you as an exercise, a thought exercise to look to this code. You want to spend 1 day, 2 days and figure out how this works. You know this, your brain is going to get rewired. Trust me on this, on how you start thinking logically. These are the kind of code you should read and try and visualize in your mind. A little bit of thought. It takes some time. You must stumble a couple of times, but slowly you will get better at it. So the trick is, I'm going to say while b. What does while b mean? While b is not equal to 0. Oh, somewhere here also. Remember, I did this earlier code. Here. Yeah, here. This, don't do this. You know what? You want to check whether a value is 0. The value is 0. Instead of telling if guess double equal to 0, too much to type. I can say while not guess. Not is a unary logical operator. It will negate the condition. Guess will be, if it's true in the Boolean context, not true will make it false. When is guess true in the Boolean context? If the number is not equal to 0. The number is not equal to 0, guess is equal to true, but not guess becomes false. So if not guess, that's how you read it. It looks like English. But if guess is equal to 0, if not guess, oh, guess is 0 then. It's false. It comes out. Right? So you can see that. So sometimes instead of explicitly checking for a value 0 or an empty string or an empty list or any empty collection, it's simply good enough to just use that variable as is. And maybe sometimes you want to say it opposite of that, you can use not, while variable or not variable, like that. You can use that. So I'm doing the same thing here. What I'm doing here is while b, that means while b is not equal to 0, I'm going to do this. A comma b is equal to b comma a percentage b. Now you know your brain is like, right? Okay. What's going to happen is this. A becomes b. This parallel assignment. Remember I told you can swap two variables without the third variable by telling a comma b is equal to b comma a. It's one level above this. A becomes b. B becomes remainder of a divided by b. Give me a point. A is b. B becomes remainder of a divided by b. Two operations. One statement. That's it. In a loop. While b. And then say print a. 19. I can't guess this. I couldn't have guessed this. 19. Wow. I don't even remember the 19 ones a table, but I'm sure now 133 is not in the 19 ones a table, is it? Yeah, it should be, I guess. Maybe. Yeah, it should be. Because if you try maybe 133 divided by 19. Oh yeah, 19 sevens are 133. I don't remember tables now. Bad. There was a time when I used to have up to 23 ones a table, up to multiplication tables up to 23 in my school days. Memorized. Slowly it got rusted. All right, but you can see that, right? 133 is divisible by 19. So is 57. I guess 57, I know it's some kind of a multiple of 19. Let's say 57. 19 is 3. Wow, it works, right? You can look at this code. Whenever you see code like this, it is sometimes the first time you might stumble and say, oh my God, programming is difficult. No. This is a complex program. This is not something that's very simple. It's not like, if you don't know this, you're an absolute noob. It's not that. It means that this is a fairly advanced kind of an algorithm. It's advanced, though it's 2 lines. In order to understand this, how it works, the best way to do it is whenever you look at any kind of code like this and you want to your brain hurts, but you want to see some graphical visualization how it works, what you do is copy this code. Okay, and then head over to your favorite web browser and go to this site, pythontutor.com. If you remember in the first session, I talked about this site, a place where it's a playground where you can try out Python code. Let's try this here. So go to this place, start coding online now in Python. Click on this link. And once you are here, this link, you can go ahead and here, right, in this place, paste it. Make sure it shows up as Python. Okay, I think, 3.11. It doesn't matter whether you use 3.6 or 3.11. No, don't use 2.7, by the way. Okay, I'll use 3.11 itself. It doesn't make any difference because I'm not using any specific syntax of Python 3.11. All these will work in all versions of Python 3. Okay, so I selected this and go down below and click on this button called Visualize Execution. So if you see this, you have this. Oh, now they have something called AI help. No, AI is everywhere. AI for everything. Someday I will not be surprised when I order for samosas in India. I'll also get AI support for it. It's a joke. When you visualize this code, you can see that it shows this pointer here. I mean, it shows this program counter, let's assume, right? It's pointing here. It's supposed to execute this line. And you can click on next. Yeah, you can see what happens here. A is 133, B is 57. This is like that ledger I was talking about. Variable refers to an object, right? they're showing it here. A is like written down, okay, 133. B is 57. Two variables are defined. And while B is not 0. So this condition is true because as a Boolean condition, it will be evaluated as true. So while this condition is true, it's going to execute this code below. So we just click on this. It goes inside the block, inside the while loop. And when you click on next now, you can see what happens to A and B. A was 133, B is 57. Let's see what happens. A became 57, B became 19. Because A becomes B becomes remainder of division as modulus of 57 by, 133 by 57. So it'll be 19, I guess, and remainder of division. Now again, go back to B again here, and B is not 0, so it's going to try this again one more time. A comma B is B, comma A percentage B. Now 57 divided by 19, I think the remainder will be 0, right? You can see what happens. Now you can see that because the remainder is 0, B is 0 now, so B comes out. I mean, this while loop comes out. The remainder of the last remainder that is there is represented in A, and that's what is printed. Magical, isn't it? Algorithms are magic, amazing magic if you know how they work. Little bit of code, wonders. It does wonders. And this kind of code, if you don't write in a language like C or C++ or Java, try it out. It's not this succinct. This is also called succinctness. That's one of the interesting keywords I learned when I look Python language. They say the code must be succinct. And I had to look up my dictionary and see what does succinct mean? Okay, you know what this means. This is what it is. Short and simple. And to the point, right? And does the job. All right, so this is what it is. And some of you might ask, oh, what if the number is like swapped? B is, A is 57 and B is 133. Let's try doing that. Let's try to make some changes. Let's go back to, is there a way to edit the code back? Okay, edit this code. Click on this link. And try 57 and 133. I sort of swap the number. Try to visualize the execution again. And click on next. Okay, A is 57 and B is 133 here. And when you click on next one more time, it goes inside the loop, of course, because B is not 0. And when you click on next this time, you can see what happens. It's sort of swapped it, right? So some of you might think of, oh, you should always figure out which is the big number, which is a small number. You first need to figure that out and swap them if necessary. This does that also automatically, right? That's why I call this a very marvelous piece of code, right? For the beginners. You can see this, and it comes out. It takes one more step extra, but you can see that it finishes in 9 steps. This is an example of what you can do with a while loop. Though while loop is suitable for all kinds of looping constructs which involve executing statements repeatedly using some kind of logic and algorithm, I've seen a common use case where while loop should not be used. I'm going to end with that, okay? Where what kind of use cases you should not use a while loop. It's very common amongst newbie programmers or programmers from other languages who hop onto Python, especially C programmers. And they do this. I want to count 10 times. I want to count 10 times. Or maybe let's make it 5 times for now. I just say I is equal to 0 while I is less than 5. I say print, I can just say counting I and I plus equal to 1. Yeah, it works, right? It works. What's wrong with this? It works. Though this code works, this is an example of an inappropriate usage of the while loop. Inappropriate. The while loop is not intended for this. The while loop is not intended for this. So the true intent of while loop is you want to check for conditions which are purely that's something that you can determine in runtime, not by a programmer. This is an example of a deterministic looping or definitive looping. You know what it means? I know for sure by looking at this code that this print statement will be executed 5 times. It's deterministic. That means because you know that I is equal to 0 while I less than 5, then you're counting I and I plus equal to 1. So this is deterministic. You are looping 5 times. It's, beforehand, you want to run 5 times. You want to execute some piece of code 5 times or 10 times or 100 times. Don't use a while loop for that. While loop is not suitable for deterministic iteration. You might ask me, what's wrong with this? This code works. This code works, but it's like using the wrong, using it for the wrong purpose, right? This code works, but it's not Pythonic. Then how do you do this? What is the right way to iterate 5 times? Or how do you do deterministic looping? For loop. For loop, my friend, for loop. So use for loop whenever you have encounter code like this. Whenever you need a requirement like this, use a for loop. So I'm going to put a comment right in here. Inappropriate usage. I'm not sure if I spelled appropriate correctly. There's no grammar checker there. Sorry. Correct my grammar if I'm wrong. Okay, so inappropriate usage of the while loop. Use for loops for logic like below. So in summary, use while loop for non-deterministic iteration or looping. Use for loop for deterministic iteration. So I'll end this video with just showing you what a for loop looks like, and we will continue the next session with a for loop, right? Okay, so I'll just show you how you can make it better with a for loop. So if you want to do the same thing in a for loop, it's much simpler. You can just say for I in range of 5 and then say print counting I. Isn't this succinct? It is, isn't it? You don't have to worry about I is equal to 0, I plus equal to 1, and all these mess and checking whether I is less than 5, and you don't need to do that. You want to count 5 times, you can just say for I in range of 5. I still have to talk about what range does. That's a topic for next video, by the way. So yeah, so you can see that for I in range of 5, you say print counting and I. And this is what you should be doing, not this, right? You should know exactly when you should use a for loop, when you should use a while loop. That's a very important, difference of for and while loop in Python. Deterministic versus non-deterministic. Python does not have other kinds of loop like do while loop. If you come from other language backgrounds, I know a language like Perl where there was a while loop, there's a do while loop, there's a until loop, there's a do until loop, there's a for loop, there's a for each loop. And enter Ruby. I think I figured out there are 20 ways of writing loops in Ruby, in a language like Ruby. 20 different ways. Python, 2 ways. Lesser to remember, easier to use. And there are some languages which have gone all the way to 1 way. Golang, I guess. Just 1 way, right? Anyways, but this is what you know. So there are 2 different ways of looping, right? Now this session, I talked about while loop. I hope to cover some more examples. Hopefully I'll do that in the next video. I will mostly focus on the for loop, but if I could finish for loop within an hour, which I believe it's a little unlikely, I guess the next session is going to spill to more than an hour. It can become 2 sessions, hopefully, I believe, because for has a lot of stuff going on inside. I need to cover that. And hopefully you will learn a lot of new interesting things because of that. And we will also revisit some interesting patterns using loop with a lot of examples. Once we learn about conditions and loops, we can do wonders. Once we know about expressions and basic statements I covered, and with loops and conditions, these are the basic ingredients which you can apply interesting algorithms and logic to write programs. So try spending time practicing all these things, and I hope you people are not just watching my video and just folding your hands and just listening to me. No, don't do that. You're not going to learn anything when you do that. The right way to learn is as you watch what I'm doing. I'm going in a slow manner. The reason is because so that I'm giving you enough time to assimilate the concepts and then try it for all the newbies. So even if you are a programmer who's coming from other language and you see the slow dragging session, the reason it's dragging and slow is because you have enough time so you can look at what I'm doing and type it on your computer. Type it and try it. That's the whole point. So the point is when you finish this video in 1 hour, that 1 hour you should have completed all the concepts I covered, and you should have some confidence like, okay, I tried this today, I tried this today, I tried this today. But don't stop at 1 hour. Try more if you need it, right? Till you become confident. Only you will know how much time you need to spend to become confident. It's like riding a bicycle, learning how to ride a bicycle. Some people will learn it just at the first go. Some people will fall maybe 10 days, 20 days to learn. I never learned a bicycle. That's a different story. I learned programming rather. So, but yeah, different people, different takes. So fine. So you can take some time out, practice all these concepts I covered, try it out as we go along. If needed, you pause the video, try it out, see what happens, try variations, see what fails. If something fails and you're not able to understand what's going on, write it on comments and I'll help you out, right? And yes, as usual, do like this video and yeah, subscribe, share, and all that, right? So I hope to get more visitors. I'm happy that there are more views coming to this kind of video series I'm making. That looks like a good sign for me. That's really nice. So I hope to see more. So thank you very much. So hope to meet you in the next one. Thank you.